Hi guys, so this next unit is all about math and chemistry. So when we're working in the lab, we deal with masses and volumes of substances. But when we read chemistry problems, we're going to be seeing units like moles and molecules. So there needs to be a way to connect the two, and that's what this unit is about. It's about finding the number of things, meaning molecules and moles, by using macroscopic things, things that are big enough for us to see and measure, like volume and mass. Okay, the scientists developed this unit. The word mole is actually a unit, just like grams is a unit for mass. Mole is a unit for the amount of something that you have. So if we look at other examples where like a word stands for a number, we know that if someone has a dozen of something, that means they have 12 of something. Or if they have a pair of something, that means they have two of something. So when we say we have 1 mole of something, that very specifically means that we have 6.02 times 10 to the 23rd particles of that something. Okay. Now, this is a giant number. So, when we talk about macroscopic things, like for example, if I had a mole of marshmallows, the amount of marshmallows I have would cover the entire world. It would be gigantic. But because atoms and molecules are so small, we can have them in these large amounts where the size in real life of your pile or of the level in your beaker would be something that's reasonable. So that's what the word mole means, and we use this unit to represent this giant number so that we have an easier time doing math. That's pretty much it. Okay. So how does it relate to the following quantities? So, in the beginning of the year, when we learned about converting units, we had these conversion factors. We put them in parentheses in a fraction form, and they helped us cancel out one unit and get to another unit. So, with the mole, we also have conversion factors to help us get from one unit to another. As far as volume goes, we only have a conversion factor if the substance is a gas. Um, the amount of gas particles, if the amount of gas particles are the same within two substances, they'll always take up the same amount of space. That's not true if you have a mole of solids or a mole of liquids. For solids and liquids, depending on the substance, they might take up different amounts of space, depending on the size of the molecules themselves. But for a gas, we're allowed to say that if we have 1 mole of a gas, it's always going to be equivalent to 22.4 liters. So this is a conversion factor, guys. I can write it as a fraction. Either 1 mole is 22.4 liters or 22.4 liters is 1 mole. So when we get to a problem and you have to cancel one of these units out, you can write it either way. Gram formula mass is a little bit tricky because 1 mole of something is equal to the mass in grams. Actually, I should say in grams per mole on the periodic table. So if you guys could take a second and take out your periodic table, we're gonna need to look at it anyway in the coming slides. But if you guys can find carbon for me, and you look at the mass of carbon, right? There's the number 12 there. If you have a single carbon atom, that carbon atom will weigh 12 AMUs, 12 atomic mass units. That number also stands for if I have a mole of carbon atoms, if I have 6.02 times 10 to the 23rd carbon atoms, that pile of atoms will still weigh 12, but it'll weigh 12 grams. Okay, so we can look at the periodic table and whatever that number is, that's the equivalent to 1 mole of that element. All right? Okay. So it gets a little more complicated when we talk about compounds, because now we have a whole bunch of different elements that are bonded together. And what we have to do is basically just look up their masses and add them all together. Where you have to be careful is looking at subscripts. So for this compound right here, I have 3 calciums, right? So in parentheses, I'm going to say, okay, I have 3 times. If you guys could go look up the mass of calcium on your periodic table, you'll see that it's 40. All right. Plus, my next element is phosphorus. Now, there's no subscript next to phosphorus, but the phosphate ion is in parentheses with this little number 2 on the outside of it. Now, whenever you have a subscript outside of parentheses, that subscript has to get distributed to everything inside the parentheses when you're counting atoms. So in this compound, in calcium phosphate, I actually have 2 phosphoruses, and each one has a mass of 31. All right, and then finally, guys, my last element in this compound is oxygen. So 2 times 4 is 8. I have 8 oxygens, and each oxygen weighs 16. Okay, so you guys can take a minute and put that in your calculator. All right, want to make sure you use parentheses correctly, or you could just do all the multiplications, get your 3 numbers, and then add them all up. And you should get 310, right? And the units for gram formula mass are grams per mole. Meaning, if I have 1 mole of calcium phosphate, it's going to weigh 310 grams. So now, guys, just like I said that these are conversion factors, like you can write them in a fraction form, it's the same thing with gram formula mass. If I'm trying to change from one unit to another and I need to cancel out grams or moles, I can write it like this: 310 grams per mole. Or I could write mole on top. In 1 mole, I have 310 grams. And you could put the number 1 there if you want to. All right. So this type of compound, this is something we haven't seen before. This is called a hydrate. And when you guys think about the word hydrate, you probably think of water. If you're staying hydrated, you're drinking water. That's kind of what it means here. It means water is bonded to the molecule. So this little dot, in math, that little dot would mean multiply. This does not mean multiply. It just means that for every 1 mole of copper sulfate, you have 5 moles of water bonded to it. Okay, so as far as gram formula mass, it's just something that you want to be careful with, because when you get to the water part, sometimes people forget to distribute and it gets a little weird. So let's just look. Copper is 64, and there's 1 of them. Sulfur weighs 32, and there's 1 of them. Plus, I have 4 oxygens, each weighing 16, plus 5 waters. So guys, that 5 needs to get distributed to the hydrogens and the oxygens. So how many hydrogens do I have? I have 10, and each one weighs 1. And how many oxygens do I have? I have 5, and each weighs 16. Okay, so when you add this all up, you get the gram formula mass to be 250 grams per mole. And again, you could write this either way. Okay, so notice that depending on what the compound is, it's going to have a different gram formula mass. Um, and because neither one of these are gases, these are actually both solids at STP, they're going to take up a different amount of space. The bigger the molecule is, the more volume it's going to have. So that's why we can't use a specific volume for 1 mole of a gas or a liquid. All right. So now that we have our conversion factors, we can take a look at some problems. So in my first question, they're telling me these are one-step mole conversions, which means we only need to use one conversion factor. So I would always start by writing out what I'm given. So in my first question, I'm given 26 grams of water, and they want me to convert to moles. So in order to convert to moles, I need grams on the bottom to cancel out with grams, and I need moles on top. So I'm going to need to use the gram formula mass of water as my conversion factor. So I would go to my periodic table. I would say, okay, 2 hydrogens weigh 2, 1 oxygen weighs 16. The gram formula mass of water is 18 grams per mole. So because I want grams to cancel out, I'm going to put the 18 grams on the bottom and the 1 mole on the top. Cancel out my grams. I multiply across, so 26 times 1 is 26 divided by 18. I get 1.4 moles. Okay. Next question. So I see the unit liters here. So liters means that I'm dealing with a volume, and helium is a gas, so that's fine. So again, I always start by writing off what I'm given. All right, and now they want me to change it to moles again. So if I want to get rid of liters and end up with moles, I need to put liters on the bottom to cancel out. But this time I'm going to use the volume conversion factor. So that's 22.4 liters are 1 mole. My liters cancel out. I'm left with the unit mole, which is what the question was asking me for. So multiply across. 536 times 1 is 536. Divided by 22.4, I get 23.9 moles. All right. And finally, guys, now they're asking us about number of molecules. So write what I'm given. And again, they want me to convert to moles. So I have to put something in here that's going to cancel out molecules and give me moles. So what conversion factor do I know? I know that there are 6.02 times 10 to the 23rd molecules in 1 mole of anything. Molecules cancel out. If you divide, make sure, guys, when you're putting this in your calculator, that your scientific notation numbers are each in their own set of parentheses. Otherwise, your calculator might do PEMDAS in an order that you don't want it to be in. So when I divide, I get 7.64 moles. All right. So those are my one-step conversions. We're going to take a look now at some two-step conversions. So again, I'm going to always just write what I'm given. 65 grams. Now, they're giving me grams and they want me to convert to liters. So they want me to go from mass to volume. I don't have a conversion factor that will bring me straight from mass to volume. So anytime you're converting from one unit to another, you always have to go through moles first. Moles is like the middleman. If you convert whatever you're given to moles, you can always then use another conversion factor to bring you somewhere else. So right now, what I want to do is I want to get rid of grams and I want to convert it to moles. So my substance in this question is water, and we already figured out that water has a gram formula mass of 18, right? So that's what I want to put here. This gram formula mass helps me cancel out grams and get to moles. Now, I don't want to stop here and solve because the question isn't asking me for moles, it's asking me for liters. So in my next set of parentheses, I want to get rid of moles, so I'm going to put that on the bottom. And I know that in 1 mole of any gas, I'm going to take up 22.4 liters of space. So now I am in the unit they asked for. I have only liters left. Now I can do my multiplication. 65 times 22.4. And then you want to divide by the bottom, which is 18. And you should get 80.9 liters. All right, let's do one more. Write what we're given, 2.4 times 10 to the 22nd molecules. And they're asking me for the mass. So I want to get from number of molecules to grams. Again, there's no conversion factor going from number of particles to mass. So if I get to moles first, I can then get to mass by using a second conversion factor. So how do I get rid of molecules? I know that in 1 mole of anything, I have 6.02 times 10 to the 23rd molecules. Cancel out molecules. I don't want to stop there because right now my unit is mole and the question is asking me to find mass. So I need 1 more conversion factor. If I want to get rid of moles and end up with mass, I want to put moles on the bottom and mass on the top. Now, for the mass, I have to look at what the substance is and I have to look on the periodic table. So I'm just going to delete these arrows because they're in my way now. So my substance for this question is SO2. So sulfur has a mass of 32, plus I have 2 oxygens. So if I add that all up, I get a mass of 64, right? So 64 grams is 1 mole of this substance. Now my moles cancel out. So now the only unit I have left is grams, which means I am finished with my conversion factors and I can solve. You multiply across first, and then you would divide by 6.02 times 10 to the 23rd, and you get 2.55 grams. Okay, so that's it for this, guys. You have to know those three ways to convert. This is just like a nice visual, and it shows you we have mass, volume, and number of molecules. If you want to get from any of these units to another, you have to go through the center mole first. You have to convert it to the mole first and then to whatever the question is asking about. And you'll notice that each time you're going to the mole, each time you're going in, you're dividing by something. And each time you're going out, meaning you're starting with the mole and converting to something else, you're multiplying by some factor. Okay, so this is just a nice visual. And there's like a little mnemonic device, demo. So that means you have to divide to get in to make it a mole, and you have to multiply to get it out, meaning to get it to be another unit aside from the mole. You could either memorize this chart or you can use, the dimensional analysis method of canceling out units, which I think is easier. But if you like this chart too, you could always draw this out to make sure you're doing the right operations. Okay, so that's going to be it for today. I'll give you one last question to try, and then we can do more practice tomorrow.